Welcome to a new edition of the Hit Rate Podcast. Today we have a very special guest, Michael Mouilleseaux from Verde Steel Treat. We took a long time actually to set up this podcast. We finally have here one of the biggest names when we talk about the heat treat industry. And believe it, myself, I have seen it, one of the sharpest minds when it comes to quality standards on the heat treat industry. So how's it going, Michael?
Doing very well, thank you.
So I do really appreciate the time. We finally are here, and I'm eager to speak about optimizing and high quality standards on heat treat. But before that, can you just please tell us about your experience in the heat treat industry and a little background of yourself and the company you represent, Ernest Steel Treating?
Sure. So I started in the heat treating industry in 1977. So I've been doing this for a couple of years now. I came to this industry as a metallurgical engineer. So that's one of the ways that people come to this. There are several entryways into this industry, but I came as a metallurgical engineer. And the first company that I started with, I started as a metallurgical technician in the lab. And as many people do in this industry, I was fortunate enough to work myself up to the vice president of operations. And it was in 14 or 15 years, it was a great gig. And I really got hooked into what this industry is. In the last 46 years, I've worked in everything from a 6-man startup business to a 120-person multi-roll pusher captive operation that arguably at its time was the largest single site heat treat in the United States. So I've seen many different things, and interestingly enough, although the magnitude of operations has changed, the issues all remain the same. Like so many other people in this industry, I've started out this and I've dracked parts, I've run furnaces, including salt pots and pack carburizing. I've done equipment maintenance, process design, quality design, furnace controls, fixturing, sales and marketing. Imagine that, sales for an engineer, sales and marketing. Implemented or upgraded computer systems in businesses that I work for. Negotiated union contracts, but certainly, last but not least, I've developed and managed people. And really that is the crux of what I do today. So in terms of day-to-day operation, do I have my fingers in it? Much to the chagrin of my managers, I still keep my fingers in what's going on. Typically, as opposed to directing people, what I'm doing is asking them questions and helping them solve problems. And that is a very rewarding endeavor to have right now. So to take what you've done for the last 40-some years and to help people learn that in a much shorter period of time and learn from that and grow from that and develop from that, that's a very rewarding endeavor.
So 1977, so that's a long time. And your education being metallurgist, you start to learn how to maintain furnaces, how to estimate parts, how to rack parts, then how to negotiate with union, how to collect money from customers, right? So that's a lot of development on the heat treat industry that it's very far away from metallurgy, but it's still core process of a commercial heat treat operation.
It absolutely is. If I learned something very early on, it's that you can have a great process, but there are so many other things that are required. So this isn't academic engineering, it's applied engineering. What this thing we call a process, you know what, it's a series of dependent operations. And your success in any singular operation depends upon the first one. So if you focus solely on the process design or the metallurgy, you're missing 90% of what's going on in the business. And if you want to be able to improve that, you need to be able to improve the business. If you're going to improve the business, you have to participate in it.
Now, we're going to talk today about efficiency, optimization, and high quality standards. So one does not only optimizes the process on the heat treat side. You have to optimize process in the whole operation of the heat treat industry. But before we get into that, I really wanted to ask you this question so you can share it with the audience about the significant impact of the heat treatment in the manufacturing industry. The heat treat processing, when we're talking automotive, in aerospace, DOD, you name it, is not always on the front row of the big picture when it comes to manufacturing, but plays a substantial role. How do you share this with your customers, or when your prospects, when you don't want to be like the lowest bidder and get the order, you want to add the value, the quality, the efficiency, and to ensure the quality of the part? And what's the significance of heat treatment in the manufacturing industry, and especially at early steel treating?
So a couple of things. One is we're in the transportation industry. That's primarily what we serve. So is it automotive? It absolutely is. Is it heavy truck? Yes, it is. Industrial lift trucks, off-the-road equipment. It's power transmission. So if you think about how is power transmitted, it's transmitted through transfer cases, PTOs, transmissions. There's gears, there's shafts. So what are important? It's the wear properties, their ability to carry a load, the fatigue properties, the torsional strength of a shaft. So you get into that, the metallurgical aspects of that, and none of these things would work without having been heat treated. Because in order to manufacture these things, the steel has to be very soft. If you're going to machine it, it's got to be in a condition that you could machine it. At that point, you don't have the strength, the wear, the fatigue properties that are necessary. So the only reason that these things work is because we heat treat them. So one of the jobs that I had during the course of my life is I actually worked for a large OEM. It was a division of Chrysler. It made transfer cases. It made 10,000 transfer cases per day. There were 14 pusher lines in this. So my responsibility was I was the chief corporate metallurgist, and then for a part-time endeavor, I ran the heat treating operation, 140 people. So what was really interesting, I did this later in life. I was in my 50s. What was really interesting about that is I was able to bring to that all of the experience that I'd had up until that time. So all of the issues that I had seen in heat treat specifications and in material specifications, I brought that to this, and I had a great time with it. And quite honestly, had they not moved out of the country, I might still be there today. But what is it that we do? So a little different take is, having worked in a captive operation like that, even the engineers that are designing these things, they knew that the component had to be heat treated in order to attain the kind of properties that you want so that the part would function. But they didn't have any idea on how to accomplish that. So was it important to them? It absolutely was. It was important enough to this company that they did it internally. So when you say, and you're working out in industry, what do? I think that you have to position yourself. You have to be your customer's expert in heat treating and metallurgy. You have to be better than anyone else they know. You have to be better than your competition. And if you're working with people like we do today, and that is tier one manufacturing companies, you have to be better than their in-house experts. You need to be able to help them solve problems. You need to understand the materials. You need to understand the processing. And when they have issues in manufacturing, or if they have issues in warranty, you definitely need to have an idea on how to help them solve that problem. And when you do that, then you have a customer, then you have a partner. Now you've got a long-term relationship.
And I do believe that's like the basic 101 of commercial heat treating. You can be the expert on heat treating, but if you do not Kick back that customer service, the level of expertise that you're mentioning, you don't have a business case. You only have a heat treat operation that it's as good as having it in-house as a captive, right? Now, having said that, when the heat treat is outsourced to a commercial heat treat, especially on automotive, which is a very high demanding on cost operation. I mean, you have to be looking about how to get optimized process, efficiency, efficacy, give the results. And I've seen a lot of commercial heat treats that are really good at what they do. That is transforming metal, right? Treating metal, but they're not very efficient. There's a bunch of those around. And I'm not saying they're bad heat treaters. They're very good heat treaters, but they're inefficient.
Right.
What can you share with us about optimizing and making more efficient a heat treat operation? And I mean a commercial heat treat operation. When you have a bunch of part numbers, different processes, different quench medias, maybe different families, different customers with different demands or specifications. How can you make and optimize one operation like that?
So you have the stereotypical commercial heat treat is a job shop, and you have many customers, none of them of which are going to be maybe larger than 10% of your business. So how are you going to optimize doing all of those different kinds of things? And that is a real challenge. And I would say that 2 or 3 of the commercial heat treating businesses that I've had the opportunity to run, that was the business model. And again, what you have to look at is you have to look at how are you going to simplify this business? Everything is not different from everything else. What we need to look at is how can we combine things? How can we come up with standardized processes that we can utilize in multiple cases? And if we can crack that nut and figure that out, then what we can do is consolidate what we do. We can put it in buckets, and then we can group things together. And if we can group things together, then we can optimize what they do. So that's in the stereotypical job shop, that becomes the challenge, and that's the methodology for that. My business today, I have 10 customers that are the lion's share of our business. So we do high volume serial production. Way back when I started my career, we had an opportunity, and a General Motors plant was closing, and they were interviewing different heat treating companies in Michigan to see who were they going to outsource their business to. And we were able to demonstrate that we could do everything that they needed to have done, and we were cost competitive. But at the end of the day, their analysis was, you've never done this before. The only thing you've ever done is a lot of small jobs, and you've never done high volume production of the same thing. And we don't think that you're suited to do that. And I was absolutely dumbfounded, because the level of complexity of what we were doing compared to what this OEM was coming in, they had a dozen parts. To simplify your life to where you're doing a dozen things as opposed to hundreds, that just seemed like heat treat heaven. They had said, you've never done that before and you don't know how to do it. And very disappointed, obviously, but what came home to me and what was obvious is that we sold the wrong thing. We were selling our technical expertise. We weren't selling our business model. We failed to convince them that what we could do for them and how we could help them do it. Now I'm going to say, fast forward 10 years after that, and we had another opportunity, and this was with 2 Ford facilities. And these Ford facilities probably had, let's say, 10 different heat treating companies that were heat treating their components. So a unique situation. I was a personal friend with the reliability engineer in these divisions. And they had recalls, and the recalls that they had were associated with heat treating. And we would talk about this. And I would say, Mark, the reason that you have these issues is it's the way that you go about sourcing this. You're always looking for the lowest cost, and no one's ever keeping their eye on the ball as to how important these components are and how important is this process to the success of your car. So I actually got an audience with this plant's senior management group. And he had asked me to come in and talk to a couple of guys. Well, it ended up being a conference room full of 20 people. And I said to them the exact same thing that I just said, and that is, you get what you pay for. You want to have this diverse base of low-cost suppliers, and that's what you have. And with these low-cost suppliers, are you getting the level of quality that you need? And the answer to that is no. And how often do you talk to these people? And how often do you have them come in? And how often do they talk to you? And it doesn't do it. So I kind of laid out a plan for this management group, and we were successful in securing all of this business. It was one of the successes in my career. But it had to do with being able to convince people of what they need. They don't know. Convincing them of what they need and how to go about doing it.
Now that you have shared this story with me, comes to my mind. I always try to give that approach when I'm selling commercial heat treat. You go there and you give your presentation. You want to make them know that you're technical capable, that you got the infrastructure to support it. You do trials and charts, and you go through distortion and cracks and IGO and everything, and you get the things right. But then it comes to the price thing. Like, well, this is our target. Like, dude, that's like 40% below my number, right? And every time I mention, I cannot grant you the level of service and quality that you're asking for with this target price. So if you want to ensure quality and customer service, this is the price. That's how I handle it. Sometimes it's not well taken. Sometimes they get the message, and it's part of business. Sometimes, especially in automotive, somebody is going to take the chance to take it at target price, and he might succeed or not. So that's my experience. But you always try to sell your service, your technical knowledge, your infrastructure, and as you mentioned, prove that you can handle the problem, the situation, and deliver. So did I get it right, Mike?
You know, I absolutely believe that. When I'm asked to quote something, and if I'm not given a target price, and I won't be given a target price, then I recognize this is going to be an economic decision. Mm-hmm. If you really are interested in partnering with me, you are going to tell me what you need and allow me to figure out if I can do that or not. And I'll be very honest if I can, and I'll be very honest if I cannot. If I can't do it for that, I'm just going to say, God bless you, go on your way.
Here's my card.
Yes. Yes.
Sure. Here's my card, my quote.
So how many times have they come back and said, well, you know, that price that was 10 or 15% less than what you were, it didn't get me what I needed, and I need to talk to you again? It's happened. Does it happen every time? Of course not. But it does happen. And I think that if you're honest with people and they recognize that you're going to be given the opportunity. Again, it's being better. It's being able to convey your sense of what you're capable of doing to your customer, so that in the event they choose to do something else or go another way and it goes sideways on them, they know where to go.
Now, having talked about costs and pricing, there's something else that we need to keep in mind, which is ensure high quality, especially in automotive and aerospace. So how do you keep running efficient operation while maintaining high quality standards and at the same time make a profit?
Yeah.
Three balls that you have to juggle.
So,
And let me make a pause there. You're, as I told at the beginning of the podcast, one of the brightest minds when it comes to quality standards. You're in all sorts of committees, very familiar with CQI 9, with AMS 17025. So sometimes, well, the specifications are not getting any easier. They're more demanding time by time, and also the cost is a factor that the customers are always hammering us with in the head with a hammer on you gotta be more efficient. You gotta be more efficient when we're talking about volume. How do you juggle those three balls? Efficiency, high quality standards, which are being more demanding every year, and making a profit.
So it's reducing complexity. It's developing robust processes. It's driving toward standardization. If you use those as your hallmark, then what you have the ability to do is to continuously improve those things. If you allow the level of complexity of what you're doing to get out of control, then you have no ability to improve it. The complexity is going to drive you as opposed to your driving that. It's pre-establishing heat treatments and methodology in racking and loading. If you think about it again, we have it's this series of dependent variables. You have to quote the job. You have to engineer the job. You have to figure out how it's going to be loaded. It has to be run. It has to be is there inspection? There is. And then there's post-processing. Post-processing is an opportunity to add value to the customer that typically you wouldn't think of. So could parts be cleaned, or could they be racked in some way that would be conducive to where when they're going to use this product afterward, it benefits them? Those are things to give some consideration to. And that's extending the value chain. That's extending your importance. That's giving you the ability of charging what you need to charge to do it. But how do you keep these high quality standards? If you have standardized processes, the automated instrumentation that we have today and the data logging that you have provides you an avenue to continuously improve that improve the process. And it's by improving the process and understanding what it is that is going to give you an improvement in quality. Now there's one other thing. We have this process. You have an input to the process, and what is it? It's your customer's parts. Mm-hmm. It's your customer's material, and you subject it to a process and you get a result. So we are always told you need to improve your process. Your process needs to be more consistent. However, if the input to those process is not consistent, there's no opportunity for a singular process to take variable inputs and give you a singular outcome. So it's about material hardenability. It's about their purchasing practice. It's about whether or not they normalize parts. It's the thermal processing ahead of time. It's all of those things ahead of the heat treating process that you need to have conversation with your customer and have them understand how important that is to allow you to give them the results that they want. Allow you. You help me and I will help you. If you don't control the inputs, it doesn't matter how consistent my process is. The variables in the inputs are going to end up as variables in the outputs. So that's a tremendous effort on our part, is that conversation with our customers. And it's continuous and ongoing.
I got a comment about the input of parts, because on my heat treat, and I don't want to be too hard on my customers, but we get a lot of material or input material, it's not round enough, it's started already, or sometimes it's dirty with oil remains or debris. And if you keep treating that, you're gonna get bad results that are gonna be blamed at you. But you have to push back. Even counting the units, they say they'll send you 100 and they send you 97 on a box, and then you have to pay for those 3 that didn't go back, that never came in, right? But that's a very hard push against the customer, but you have to educate it. Otherwise, you're going to end up losing money on quality claims or inventory claims, and your process is not going to be as good as if it was a good part from the beginning. So how hard do you push back to your customers without creating a friction? Because customer is always right according to marketing law, right? But sometimes they send you the bill with 100 parts in a box and they're only 92, right? So they're not right during that time. How do you educate them? And just for that's an extra question. We didn't have it on the script, but I think that's a very valuable. How hard do you push back the customers when they're not right?
Okay, so the quantity of parts. I said that you have to simplify, you have to have standard processes. So when the parts come in, you need to have a way of verifying what you're receiving. If you can verify what you received and you don't receive what the customer said it is, that's the time that you go back to the customer and say, I want them focusing on receiving the parts, running the parts, racking the parts, inspecting the parts, returning them in the bin, doing this in the time frame that the customer is required. When there are issues like that, I think it's important enough that that's where I need to come into play. So I come into play, to some extent, you got this white hair and it looks like you've been around the block 1 or 2 times. And that gives you a little bit of credibility. Not a lot, but a little bit. You have to be, again, it's convincing people of what it is. So I'll give you an example. You said what parts are oily or something like that, okay? So we have a customer, they broach gears. They broach a spline in the ID of the gear, and they use a water-based coolant in the broaching, and the compound has got boron in it, okay? Do I know that when I nope, didn't know that when we quoted the job. And we run the parts, and we notice that the case depth on the exterior of the parts isn't uniform. There are areas where you've not diffused carbon into the surface of the part at the rate that you have other places. Why is that? So we go back and we have that conversation. And what is it that you're using as a broaching compound? And it's got boron in it. Do you understand that boron inhibits the diffusion of carbon in the surface of the parts? So why don't you wash that off? Well, here's the gig with my washing it off. If I have 10,000 parts, when I start out, my wash is very clean and I've taken it all off. By the time I've got to the 10,000th part, I've contaminated the wash with all of this broaching fluid that you've used, and I'm just putting it right back on the part. So where it needs to happen is when you're finished, you wash the part. You wash the part. Then I can give you what you need. Well, how do you do that? And how can they accomplish that? It's performing an operation in the time when it's most economical and it's most effective. Having me do that after the fact is not very economical and it's not very effective. And if you think that you're going to go down the street and someone else is not going to have this same problem, let's think about what's the root cause here. This problem is going to rear its head at some point. Maybe they won't tell you about it. I'm here to tell you about it. So it's that conversation with the customer. Because it's a relationship, we can talk to each other freely and frankly, okay?
It is, yeah, and you haven't said that it's a relationship, and especially in heat treat on big contracts, big parts, it's a marriage, and you're there for them. It's more than a relationship. I mean, you have the PPAP for their parts, the PSW for their parts. You're gonna roll them for quite a while, and a divorce might be very costly. to either side. So you better get and talk
So
things through,
folks are
right?
very fond of saying, I want you to run this to the PPAP process. And I can run it to the PPAP process, provided you continue to give me product that complies with the PPAP. As soon as you change something, the PPAP is no longer applicable. Do you want me to run this to the PPAP if you've changed the hardenability of the material and it's now half of what it was? I don't think so. I don't think so, because you're interested in what are the results of that. So you have to keep your end of the bargain, and that has to be held in order for me to do that. How many times have you heard a customer said, well, I changed this and I didn't think it would have any effect on you? If I go back to my customer and say that, well, I made this change and I didn't think it would have any effect on the product, that's not an acceptable discussion to have.
No, especially in automotive, they'll go nuts.
Exactly. It's not acceptable. Similarly, you are held to the same standard as I. So that relationship, when you need something, and as we all know in this business, our customers have issues, they have production issues, they need help in doing more than what you contracted to do. I'm supposed to do 10,000 pieces a week. They weren't able to produce anything last week. This week I've got to do 20,000. Okay. So do I go to the PO and say, you know what, I only said I was going to do 20,000, 10,000. I wasn't going to do 20. That's not the right answer. So when they come to me and say that, or I need you to work a weekend, or I need you to do something special. If we have a relationship, I owe you something more than that. Our relationship isn't the PO. I know you, you know me. I know about your family. You know about mine. We have a relationship, and I'm willing to do something for you above and beyond. And that's what makes this business different. You're not clicking on a window on the internet and having it delivered the next day. You're calling me on the phone and we're having a conversation. I like this.
That's a very true statement. I've never seen it like this. It's not like a click and deliver. It's not like a Prime service. It's something else, very unique.
Right.
Thanks for sharing that. I like that. Michael, 1977, that's when you started. So I believe you've seen some trends in the heat treat industry. Maybe, I don't know, electronics, controls, nitrogen, methanol, endothermics, SCADAs, CQI9, you name it. You've seen some trends around. But I don't want to, see what trends there were. But right now, we're in a position that we're seeing significantly big trends going forward. What are the trends you're seeing in the heat treat industry? We actually worked together on an MTI meeting that they talk about AI. They're always talking about pushers against batch that you have a podcast on. What are the trends that you're seeing? There's going to be commercial heat treat work. Companies would like to keep it captive. That's maybe one trend. Now that with all the nearshoring, is there enough people to run a captive shop that are heat treat knowledgeable? What are the trends that you have seen in the past years that are going to occur in the next 10 on the heat treat industry that you think that will impact our business model?
So as opposed to technical changes like an oxygen probe or ferritic nitrocarburizing or low pressure carburizing, gas quenching, those things, those are the sexy things in our business, right?
Yep.
I've got LPC and gas quenching. Well, God bless you. I'm happy for you.
Yeah.
Okay. I'm again, what we do, it's this dependent series of operations. And you're saying I've changed one thing, and that's going to change the entire industry. You're short-sighted. What we're judged on is we're judged on the results at the end. We're not judged on anything else. Whether you carburize something conventionally or you LPC carburize it, is cost going to come into play? Are there some people that are going to look at things like IGO and microstructure, and if you've got gas quenching, are you going to try to sell it on the basis that I've got the best distortion that's known to God or man? Of course you are. Of course you are. But at the end of the day, if you don't accomplish that, you're just another one of those. So what do I see in industry? The trend that I'm looking at that is going to be the single most important thing is going to be data analysis. It's what we do and analyzing over time what we've done and how do we truly improve it. Continuous improvement operations right now, a lot of it is empirical. I look at data of 20 runs of something, and I make an assessment of what I think is different. Do I have data? I do. Is it easy to crunch? Is it easy to put together? Is it easy to compare? The answer to that, for me today, is no. So is it machine learning? Is it AI? AI is the real sexy term, right? I mean, it's not AI, you've got it going on here. Is it machine learning? It's something like that. But if we can take large data sets, which that's the trend, large data sets, analyze it, then you could truly say, this is what I need to improve this process. And I'm not just talking about a heat treating process. How about the process of receiving your customer's components? How much time does it take? What are you doing? How do you verify it? All of those are the things that incremental improvements in every one of these dependent operations is what is going to give us a more finely focused heat treating operation. So it's looking at all of those things. So having done a little bit of that, a little bit of shipping and receiving, and a little bit of loading, and a little bit of quality control, and all of these things, you get an appreciation for the interplay of them. You know, I think it was Vince Lombardi. Vince Lombardi said that a great plan executed poorly has the exact same results as a poor plan. So it's execution. What we do, it's execution. What's in addition to that is after we have a plan and we execute it, we look to see how we can improve it. We improve the plan and we execute it. But if you just have a great plan and you don't look at how well is it being executed, you're missing something.
You are well said. Amen. Now, just want to go a little deeper on the data analysis. A lot of commercial heat treaters, they have SCADA systems, and we're generating a bunch of data. And I'm talking specifically about the process. Sure. But there are very few that analyze that they have the data, but there are very few that actually, how can we improve? Yes. Do you have an opinion on that?
Where, when I said I think that's where this industry is going, that's where it is. We don't have a standard, right? For how do you store this data so you can document what it is you did? If you've done the same thing 10 times, can you compare exactly all of the furnace parameters? It's not easy. The furnace recovery time. So if the furnace recovery time is in X amount of time, it's a batch furnace and it recovers in an hour. If it takes an hour and 5 minutes, then it takes an hour and 10 minutes. Then it takes an hour and 15 minutes. How long does it take before it gets your attention, right? We, as humans, we're really good at noticing differences, and we're really poor at setting multiple parameters. But there's got to be enough of a difference in order for us to notice that. So if there's a difference of 15 minutes, then you say, something's going on here. So what's going on? Is it a clogged filter on a combustion blower? Is it the fact that the burners are out of tune? There's something there. There's something there. And are there enough sensors available? The short answer is there are. Are they all married together? And are they analyzed in such a way that we can self-correct? And the answer to that, as far as I know, is no. We're not there yet. That's where I see this thing going. And then the last piece of this is obviously the metallurgical properties. So you don't inspect quality into a part. The only thing that you're doing is you're just reporting in on what you did. So if we're able to analyze what it is that we've done, this process that we talk about, and we look at the results of that, if we can compare these things on a very finite level, we can start to improve what it is that we're doing. And people are no longer going to say, you're just another blacksmith. They're going to say, you've got a manufacturing process that I want a piece of.
Good statement there. Data analysis. I'm gonna trying to improve. Maybe we can have another conversation about how to analyze heat treat data. That's a whole different story, you know.
Yes.
Everybody is taking data acquisition, but very few people are talking about data analysis.
Right.
It's been great talking to you about all this efficiency, high quality, the trends, data, commercial. We talk a bunch about commercial, but now let's go a little more into the team, the people that actually run a commercial heat treat, which are individuals. I don't think we're going to be replaced any soon by computers, commercial heat treaters, but that takes people. And I do believe that the amount of people that it's leaving the industry because they're retiring and you know, they're going on with the new chapter of their life is not getting replaced by the new generation. So we're losing a lot of experience and we're not replacing it. What would you advise or what would you share to the new generation of heat treaters, to the young guys that just apply for a heat treat job and just like you back in 1977, they're in the metallurgical lab and they want to go into the corporate ladder? What advice will you give to that guy that just entered the heat treat lab or the quality or the quality position or the maintenance position, that they're getting very passionate about heat treat and they want to make a name for themselves?
So what I said is that if we have 12 or 15 furnace operators, they all started on the ground floor, racking and stacking parts. And we said to them, if you can do this well, we will give you an opportunity to do something else. You could become the person that is running that furnace. You could be the person that is maintaining that furnace. You can be the person that's checking the parts that are coming out of that furnace. There are opportunities here. The only thing I need from you is a work ethic. You show me that you want to work. You show me that you'll come to work every day, and we'll teach you how to do that. And there are tools available. Obviously, the MTI has some great training courses, and we've utilized that with a lot of people. And it gives them something other than me to listen to, which I have to admit that I don't know why you're still doing it at this point, but you know, you have the ability of doing that. And there are young people today who want to work. There are. The task is to find them.
Yes.
And it's not easy. I don't, you know what? And we are very fond of saying kids today. And I'm sure that in 1977, they were saying the exact same thing about me. Kids today. What's different is that today is different from yesterday. So you know what? Just accept that and move on. Now, in the technical field, that's a little different. You know what? They don't teach metallurgy like they used to.
They do not.
They don't.
I'm totally 100% with that.
Right. You know, it's materials, and we're looking at polymers and plastics and ceramics and composite materials, and the metallurgy is just one small subset of that. And to the American public, the person on the street, they're going to say that steel is so yesterday. Why would and kids, well, that steel was so yesterday. We're not making things out of that anymore. And you find out, well, in fact, we are. So those electric cars, the gears in those electric cars are made from the same material that the gears that we put in cars when they had way back when they had internal combustion engines. And in fact, we're making those gears better, and we're heat treating them more precise. And in fact, those gears are quieter than there used to be. So you need to know more about what you're doing than we did before. But you're not making those gears out of plastic. And you're not 3D printing the gears. These gears are, the evolution of gear manufacturing is long and storied. And the reason that they can be as quiet as they are is because they have as much experience in doing these things as they have. So what I would say to a young person today is there are numerous opportunities here for you to take advantage of. You need to have an open mind, need to understand what it is that we do or learn what it is that we do.
No, Mike, it's been
we're good.
That you have shared all of this knowledge. For me, it's like a lot of experience on steroids, right? So thank you all for that. I do struggle with a bunch of stuff that we talked about, and what I take from this podcast, you emphasize a lot on simplicity. We're in a very complex industry, but can be simplified in order to get a successful and efficient operations. Customer relationships. It's a relationship with the customer. It's a fine dance. With the team, you have to teach them. You have to teach them how to heat treat things, and you have to tell them that if they have a work ethic, I really like that. I mean, the limit is in the sky, right? So I got a lot from this podcast. Thank you very much. I would like to appreciate that, and hopefully the audience gets a bunch of that. So it's been great talking to you. Thanks for sharing that. What I tell my guests in the podcast is that we heat treat stuff, and that's what we do to make the world a better place. And you're one of those guys that gives a lot of their time. You like to teach. I have seen that a lot, always giving conference, talking to the younger guys. You give an opportunity. Like me, when I was back on much more younger, you give me a very good welcome to the MTI, very open to talk about standards, answering questions. So I would really like to thank you in public for that. You've been a great mentor to me, a great businessman to follow their path. And I just want to thank you for that. And so thank you very much, Michael. That was Michael Mouilleseaux for Steel Trading, one of the brightest minds and brightest business mind when it comes to commercial heat treating. Thank you so much, Mike. It's been a great podcast. An honor to have you.